Hello everyone. So in today's data structure video, we are going to discuss on the concept of binary search, where we look for a particular item by comparing the middlemost item of the data collection. So here we compare the item that we want to search with the middlemost item of the data collection. So unlike linear search, we are not going to check for every item one by one. Okay, and if my item is getting matched with the middlemost item, we are good with the search. So we have the successful search. And if my item value is less than the middlemost item value, then I will be checking the left subarray. Okay, I'll check from my indexing 0 till my mid minus 1. If my item that I am searching, that value is more than the middlemost item, then I will shift my search to the right subarray. That is mid plus 1 to the side subarray. Okay. Uh, One key point to note down here is for binary search, the array should be sorted. So if we are already getting the data collection which is already sorted, we are good. Otherwise, before performing the binary search, do not forget to sort your data collection. So here I'll be taking an example of array. So I have put it as array. Okay. I'm going to describe by an example. So here I have an array of 7 items and 27 represent the middle position. So this is my mid. And I want to perform the search for 102. So I'm going to check the value 102 with the middle value, which is 27. This is not matching. Plus this is more than the middle value. So we already discussed, right? If the item that I'm searching is more than the middle value of it, then I should search only the right subarray. So I'm going to search from my middle plus 1 to my end of the array. So the next search would be this. Now, again, I'm going to find the middle element of my right subarray. This is my middle element, right? And I am going to check if 102 matches the middle element. Yes, it matches. So this is the successful search. So again, just briefing on these steps. Number 1 is to calculate the middle element and then check if the item value matches the middle element, fine. Otherwise, if it is more than the middle element, then perform the search in the right subarray. Again, get the middle element, perform the search. If it is matching, good. If it is not matching and more than the middle element, then again move to the right subarray. If this value is 12, like for example, if it is 12, then this is less than the middle element. So in that case, what we have to check? We have to check the left subarray. That is starting from 0 indexing to mid minus 1, right? Um, Moving on to the hands-on activity, I'm going to perform binary search in C++. So I'm going to define a function as find, where I'm going to put my integer array and int data, which I would be checking if present in the array or not. Okay, so before defining my function, let me declare the array in the main function. So I'm going to declare my int array of size 7. So for simplicity, let's take the same values that we took in the example: 2, 12, 23, 2, 12, 23, and then we have 27, 100, 102, 2, and just one. Okay, then I'm going to call my function find. So int location equal to find. I'm going to put int array. I'm going to pass the array and the data that I want to search. So I want to search for 102. Okay. Then if location is not equal to -1, then cout element found at location, just print location +1. Otherwise, cout element not found. Okay. Yeah. Now let's define this function find. So here I'm going to take one low bound, which will be 0. Then int upper bound, which is my size -1, that is 6. This size of array -1. Then I'm going to define midpoint as -1 now. Then I'm going to declare one more variable, comparison, which will help me to find the number of comparison we have performed in finding that particular value. So currently it is 0, and index is -1, which I would be returning from this function. Okay, so the first step is while loop. So in my while loop, I'm going to check if my lower bound is less than equal to upper bound. And the first step is calculate the midpoint. So find middle point. So that is midpoint equal to low bound plus bound minus lower bound. Okay, and divided by 2. Okay, we have found the middle point. Now we are going to find the data. So we are starting our data found activity. For this, check if int array midpoint is equal to data or equal to data, then update the index to middle point. Okay, and I'm going to break because successful search is done. So I'm going to put the break statement. Otherwise, the first check is if my data is larger. So if int array at midpoint is less than my data. So at that time, what I'm going to do, I'm going to check the upper half, right? That is the right subarray. So my lower bound will be mid plus 1. So midpoint plus 1. Else my data is smaller. Okay, so data is in lower half, that is the left subarray. So I'm updating my upper bound as mid minus 1, midpoint minus 1. So we are good till here, and don't forget to return the index. So I'm going to return my index value. Now, as I mentioned that I put my comparison one more variable, okay, to check if how many comparison we have performed uh, for this search, right? So in while loop, I'm going to increment the value of comparison, and before returning, I'm going to print the total comparison that we did. Okay, all right, let's run this program. Total comparison made only 2, and element is found at location 6. See, we can see it is at location 6. If we would be doing the linear search, the total number of comparison we will be doing would be 1, 2, 3, 4, 5, 6. So, and in binary search, we can find the value in 2 comparison itself. Okay, to check more details on comparison, wait, I'll I'll print the upper bound and lower bound in the while conditions for more readability. So I'm going to put comparison plus 1, moving on to the new line, then the lower bound for that particular loop. So lower bound, sorry, just printing the value of lower bound, then the space, then I want to print the upper bound, and it's printing the value of upper bound. Let's run this program. So in the first comparison, I'm checking the entire array. Okay, oh, I'm sorry. Let me rerun it again. Yeah. So in the first comparison, we are checking the entire array. And in the second, I have moved to the upper half. So I can see my lower bound mid plus 1 from 4 to 6. So we perform total 2 comparison, and the element is found at location 6. I'm going to provide the GitHub link of this code in the description section in case you want to access to perform more operations. I hope you liked the video. If any concern is there or you want me to touch on more topics related to binary search, please put in the comment sections. Thank you, and do subscribe the channel.